Hello and welcome to CS264 Software Design. This is lecture 18 and it's entitled Working with Software Design Patterns, Creational Patterns. Essentially, I'm following on from lecture 17 in week 9, where I look at creational patterns and their implementation using C#. Normally, I would give 5 short lessons for the second lecture of the week, but I decided this time I would give a pre-recorded longer lecture that focuses on the patterns of interest, and particularly I'm interested in factories. So we're going to learn about factories as design patterns, and we'll see how these patterns can be implemented in C# using some specific examples. I'm going to try to use the examples around generating shapes, because that's the kind of work that you've been doing in your assignments, and this may help with the last assignment, assignment 5. So once again, as I said before, I'm using and would recommend this Design Patterns book, Diving to Design Patterns by Alexander Schvetz. It's really accessible, it's readable, and it has that accompanying website, refactoring.guru. You can find everything you need to know about how to implement the design patterns on this website. And it really is excellent. Lots of examples in C#, in fact, lots of other languages as well. But for our purposes, C# is good. And again, as I said, I bought my copy for €10, which is a brilliant price for the book and the examples. And I'd certainly recommend it as a book, to support this module. Remember, we're mostly focused on the implementation of patterns as part of a software design course in C#, rather than looking at design pattern theory. And this gives you some theory, this book, but it's a very practical book and very, very useful. Very useful. Okay, so let's get back to talking about creational software design patterns. So these again are concerned with the way in which objects are created. Okay, and as I mentioned this last time, the patterns reduce the complexities and the instability by creating objects in a very controlled manner. What does this mean? It means because the new operator is often considered harmful. It scatters objects all over your application, and it would be much, much better if object creation and disposal were managed in a controlled manner. That's why we want to have these creational design patterns. So over the lifetime of an application, it becomes challenging to change in implementation because the classes become tightly coupled. So we can use creational software design patterns to address the issue by decoupling the client entirely from the actual initialization and instantiation processes. So for the rest of this lecture, we're going to be interested in the factory design patterns. And there are 3 of interest: the simple factory, factory method, and abstract factory. So a little bit of work before we can get to abstract factory, for example. But each of these patterns are useful in themselves. And something to remember, and I'd like to point out initially, is that simple factory isn't one of the original Gang of 4 patterns. Okay, it's a kind of a factory pattern that may evolve into factory method or into abstract factory. And once again, I'd recommend I'm using some of the information from this book here. Excuse me. So, what do we mean when we use the term factory? So according to our textbook, okay, and you can see their full reference below, a factory is an ambiguous term that stands for a function, method, or class that's supposed to be producing something. Most common factors produce objects, but they can also produce files, records in databases, etc. Okay. What is key here really is that factories produce objects. And remember, the point of the creational patterns is that they mean we don't have to use the new keyword directly. So in C# or Java. So any of the following could be referred to as a factory, and these are the examples that are given in the textbook. A function or method that creates a program's GUI, for example, a class that creates users, a static method that calls a class constructor in a certain way, and any one of the creational design patterns. And we're interested in this latter option here, of course, for this particular module and for this particular lecture. So before we get to all of this, we have to look at the phrase creation method. And there's a really nice summary of this in the book. And we often see this term creation method when we read about factories in this book or elsewhere, and there are a couple of ways of referring to creation method. And so the first is in the book Refactoring to Patterns. Creation method is a method that creates objects. Okay, and it applies that every result of a factory method pattern is a creation method. And the reverse is not always the case, of course. Okay, Schvetz tells us that you can substitute the term creation method wherever Martin Fowler uses factory method in his book Refactoring, which is a great book, okay, and whenever Joshua Block uses the static factory method in effective Java, okay. So again, you are familiar with Java, and you may know this book already. So if you see static factory method, it means creation method. So what happens is that the creation method is just a wrapper around a constructor call. So it's a method that wraps around the constructor. And it may just have a name that better expresses your intentions. We saw this when we looked at singleton in the last lecture. It may help to isolate your code from changes to the constructor. Okay. Could even contain some particular logic that would return existing objects instead of creating new objects, as we saw with singleton. We could call such methods factory method as well, because it produces new objects using the following logic. The method creates the objects, and since all factories create objects, this method could be clearly a factory method. But there may be some confusion with the pattern factory method, which we'll see a little bit later. So you have to be careful about that as well. Okay, so we could call it creation method, or we could call it factory method. Okay. Now we also have what's called a static creation method. And a static creation method is a creation method that's declared as static. Okay. So in other words, it can be called in a class and doesn't require an object to be created, okay, in order to be able to use that method. So when a static creation method returns new objects, it becomes a kind of alternative constructor. And again, we saw this with singletons. Static creation methods are really useful when you have to have several different constructors that have different purposes, but their signatures match. That's impossible in most modern languages because, you know, it's the type in the parameters that define the signature, in addition to the name and the return. So you could have a constructor, for example, that would be static void x, and it has int y. Okay. Well, that would be the same as static void x int z, because it's the int that matters, the parameters that help define the signature in this case. And sometimes we want to have that kind of thing, and we can't do this. You know, in other words, we can't overload essentially the constructors in a way that allows us to be able to have the same parameters and same return types. Okay, so we can use static creation methods to help with this. So they're useful then also when you want to reuse existing objects. So instead of instantiating new ones, and again, we saw this with singleton, constructors in most programming languages, you have to return new class instances. So inside a static creation method, your code can decide whether to create a fresh instance by calling the constructor or return an object from some cache or pool. And we saw that last time when we looked at how we might use a singleton to do load balancing, for example. Okay, so we're really interested in factory method, and abstract factory. That's why we're here today. Okay, so when we're working with software patterns, we do see references to these. Okay, and in order to distinguish between the class of factory patterns, I'm going to, and as others do, of course, refer to factory as simple factory. Okay, and then factory method and abstract factory. Okay, so they're all related, different approaches to creation using factories. Okay. So you sometimes see these referred to as smart constructors as well. It's a nice phrase, and it's useful to have, and in case you see it anywhere, you know, it might be good for interviews too. So a simple factory then, let's have a quick look at the definition, creates objects without exposing the instantiation logic to the client, and it refers to the newly created object through some common interface. It's a simplified version, essentially, of factory method, which is described next. And the factory is only one implementation, no subclassing. Okay, so we need to remember these as we work through the rest of the lecture. A factory method defines an instance for creating objects, but lets subclasses decide which class to instantiate, and refers to the newly created object through some common interface. It is based on inheritance. Factory method is all about inheritance. Okay, so the factory is generally used when you have some generic processing in a class, but want to vary the object generates using a creation method in the subclass. Okay. So for example, if we think about the simple factory, again, we could have a factory that generates shapes. And then each factory would generate a simple shape for you. And you know, you have a class to generate a shape class. You call, if you want to have you want to create a circle shape, you just generate a circle shape. If you want to have a triangle shape, you generate a triangle shape. But with a factory method, you say, give me a shape called a circle, and then you assume that there's somewhere in the class hierarchy there will be a class that creates a circle, a class that creates a triangle, for example. But you never call that class directly. You just say to the factory, give me a circle shape, and the factory gets responsible for this. Okay, so an abstract factory, on the other hand, then, that provides an interface for creating a family of related objects without explicitly specifying the classes. So the factory uses composition to delegate responsibility of creating the object to another class. So it doesn't use inheritance, it uses composition. It's used when you want to be able to create families of objects that need to be similar, or they might have common unspecified base classes. So I was thinking about the examples for this, and if we go back to our shapes example, we could have a class of shapes, which would be generated by a factory, circle, triangle, well, let's say triangle, rectangles, but let's say we wanted rounded shapes and cornered shapes, then essentially a cornered square is the exact regular square, if you like. It's just the exact same as a rounded square with round corners. So, but you would actually but they would still belong to their own factory. So you'd have maybe rounded triangles and rounded squares, and then you might have regular squares and regular triangles, and then so the rounded ones are all part of a single class or group as well, and the regular ones are all part of their group, but actually the squares from both would also be squares, So there's ways of looking at this additional layer or level of abstraction, and that can be provided by an abstract factory. Okay, so you have to be careful that you don't confuse these simple factories with one of the creational design patterns. In most cases, simple factories, they're just an intermediate step of introducing factory method or the abstract factory patterns. Okay, you can level up to those if you like. So I'm going to be doing that later in this lecture. I made a little mistake here, so let me just correct this. That should be simple factories here. That's a bit of a typo. Okay, a simple factory is not one of the original gang of four patterns. I said at the outset. Your simple factory is usually represented by a single method in a single class, and the method may evolve and become unwieldy, so you might have to decide to extract parts of the method into subclasses and ultimately turning it into a factory method pattern. And you've probably seen that in your assignments as well, where you started off trying to create circles, and I say, well, I want you to do squares, but I still want you to do the same kind of work. I want you to draw squares and draw circles. So, the factory method, then, that's a creational pattern that provides an interface, okay, for creating objects, but allows subclasses to alter the type of the object that will be created. And so if you have a creation method in the base class and subclasses that extend it, you could consider using the factory method. So that's a good reason as to when you might use factory method. And again, an abstract factory, again, is a creation design pattern. It allows the producing of families of related or dependent objects without specifying their concrete classes. Okay. Again, there's lots of different kinds of definitions, but you get to see these in an actual example. Okay, so let's go and have a look at the simple factory pattern. So here we have a simple factory. I've produced the UML for you so that you can see this. The textbook that I recommend didn't explicitly give us a simple factory UML diagram, although there are UML diagrams, beautiful UML diagrams for the others, which I'll use later in the class, but I've decided I'd make some of these for you along the same line so you can understand the same language that's been used, okay? Again, the simple design patterns, they don't belong to the simple factory design patterns. It doesn't belong to the gang of four at all. What happens here, you can see from the client, so we have a client, okay, that has some class that does stuff, and one of the things the client does is it uses this simple factory. Okay, and the simple factory then is an abstract class. You can see this because it's italicized here. Okay, the class name is not italicized here. It's a concrete class, an abstract class, and we have the simple factory then deals with products. Okay, and we work with these products here, so it returns an instance of several possible concrete products that are based or subclasses of this product. So, you could think in terms of, the product being a shape, and the shape does something like, for example, that you can draw the shape, or you can maybe calculate the area of the shape, or do something with the methods that are in here. And we specify this abstract class in an abstract way here. And then the concrete products would be expected to also implement something. So actually, this something here is not the same as this something. It just means that we have some classes. Okay, but the somethings in the concrete products here definitely are the same as this ones here. Okay, so it's a useful exercise to be able to understand how these work. So each subclass, this here, so this could be a square class, a circle class, a triangle class, each implementing or each subclassing shape class, for example, and then we can say, give me a shape, and we get the shape for each of these. We choose the appropriate one. So it returns, the simple factory then just returns an instance of one of several possible classes depending on the data that is provided. I might say, give me a circle, or give me a square. So here we really see that the object instantiations that are returned, like concrete product X or whatever it could be A, B, or C, they've got the same parent class, which is product, and methods, but they are all different. Okay. For example, as I said, square and triangle will be both considered concrete instantiations of a shape. And so I've produced kind of a little diagram here to give you an overview of how it works. And so this is slightly different in some respects, because in the previous example, I would have had an abstract class here, and they would inherit an abstract class, but because that's a way to do inheritance in C#. But of course, we can also use an interface to do this. Okay, it doesn't have to be an abstract class, and then it implements the methods or tells you the methods. Of course, we want to use if we want to utilize methods in the base class here, where we actually provide some concrete methods that sit in this abstract class here, then we can do that. The ones that we don't have to override in the subclasses. But of course, if you have an interface, you don't do that at all. Okay, so the fundamental principle then of the simple factory design pattern is to create an abstraction that decides which of the several classes to return, and then it returns one of those. So for example, we could have a shape factory that returns shapes. So then you call the methods of that instantiation without ever knowing which subclass you're actually listing. Well, you probably have some idea, of course, but you built it. But the client essentially that uses the factory doesn't really know which one has been called. You could have a client requesting a circle, or requesting a triangle, or requesting a square here. Okay, and it just requests that in a way. Give me a square. Give me a square shape. Give me a triangle shape. But the actual class that ultimately implements, or the new instantiation that we have, it might not be called square at all. It could be called, bananas, and this could be called oranges. It doesn't matter what it's called. You don't have to know what those classes are called or what they do. All you need to know is that I have a shape, and I understand how a shape behaves because I have the shape here and description, and as long as it works, the shape factory returns essentially an I shape to me, and I'm able to use that to be able to call the appropriate methods on that object. So as I said, you call them methods of the instantiation without ever knowing which subclass you're actually using. You have a sense of course it's a square class, and of course it's a triangle class, but you don't know the class. You don't have to know the class. Okay. What's important, of course, is that you're not using the new keyword directly. You're receiving the object from the simple factory. So here, the abstract product from the earlier UML diagram could be realized, as I said, as an interface or as an abstract class. And that depends on whether you want to be able to use something that sits in here, in this thing here. Whether you want to use some of the base class functions or add some functionality in there that you want to work with. That doesn't have to be implemented by each of the subclasses. Again, here I'm calling iShape because I'm using an interface, and previously, I would have used product here. Sometimes you may see abstract and the name here in this UML description, but it depends on the flavor of UML that you're using. Okay, but you've seen this, and if you're using, say, plant UML or something to generate your diagrams, then they'll look a little bit different again. Okay, so I have a demo here for you, which I'll work and hopefully should show you some of this in practice. I'll just swap over to Visual Studio Code, and oh, en route, this is the chapter I'm using for creational design patterns from this textbook. Starts on page 72. Okay, so just so that you have that, let's have a look at the code. Okay, so I have a. Let me just go here actually. So so if you go to week 9 of the zips, you'll see that I've got some of the demos from earlier, and the lazy example, the load balancing, the examples. I think I've uploaded some of those already for you. But here I have a bunch of other programs: my simple factory, my other simple factory, my factory method, and my abstract factory, and you can access those and use them. Okay. Okay, so here we are with my simple factory. Okay. So I've got a class, a sealed class here called simple shape factory, and that's our factory. Okay, it generates the factory. So it creates shapes. And really what it does is it has a single method. This is the creational method that we talked about earlier, and that's get shape. And it pulls back this shape, okay, for us. And we can have a string that tells us which type of shape we want, and we can say, well, if the type that's passed through says give square, we return a square shape, and if it's a triangle, we return a triangle shape. Okay, and that's fine. We have an abstract class here called shape, and all it does is provide two abstract methods called draw and show. It doesn't provide any concrete methods in this abstract class here, but it's the abstract class. So we have the sealed class. So if we have the sealed class, it can't be subclassed, as we know already. So we have a sealed internal class square shape, which inherits from shape. And all it does is it overrides the as expected, the method draw and the method show that were specified in the abstract class here. Okay. So, and all these do is just say, here's the message from square that I'm drawing. Here's the message from square to say I'm showing. And show might be just to show the details, of this. Don't have any other internal details related to these particular shapes here. So I create a second instance, a second subclass called triangle shape from here. Again, and I override the draw and show methods for those. Now I have a client class, and the client really is the program, and because, but you could have a program and then create a client that does all that work as well. And so the main point here is that I have a simple factory, and what I'm doing is I'm creating a shape factory here. Okay, so I'm creating a new shape factory, and this is the factory instance, and then I'm just asking that shape to use a creational method to give me a square, and I'm able to pull the square from there. I get that new shape, and then I can show the shape and draw the shape, and then it's done. I could just ask for a triangle and it would be just as that. So let's run this and see how it works. Okay, here's my simple factory. I'm showing and drawing the square, and that was it. I could have asked for they're locking my accessibility. Some reason it didn't behave properly. Okay, so we're grand. Let's go back now, and I wanted to look at my triangle here. So let's copy this here. Okay, and let's have a look at triangle. Because I know from when I wrote the factory up here that I could deal with triangles. Okay, of course, if I asked for a circle, I would get an error. We need to handle that, of course, as well. So we need to know about those. And I'll just do shape that draw. So. So we have our square and our triangle. Okay, and it works as we would expect. First we get our square, then we get our triangle. We're just pulling a shape from the factory. Okay, so that's how it works. Okay, now you may have noticed or seen beforehand that I had one called my other simple factory, and really the reason I did this particular one was because it was fairly straightforward as far as that. This time I'm using an interface. So we have creating this enumeration called square and triangle here, so I'm not dealing and passing with strings for my shape type. So I kind of like doing that rather than having dealing with strings. And now I'm passing this. This becomes a publicly available within my program or my assembly. And so I have my C class again, which is a shape factory. And this time I'm looking at a creation method called getShape that returns an iShape, which is an interface. And again, I'm doing the shape, looking at shape types. So instead of it just being a string that's passed, I'm looking for a square, and triangle. And I could also then throw an error here. I could wrap this, of course, in a try and catch and throw an error if there was a shape that was requested. It wasn't in the enumeration. So that's a nice way to do this. And here's the interface. So this time we're actually using an interface for inheritance. Okay, so we're using that instead of an abstract class. And so now everything else pretty much works the same, except I'm inheriting from iShape rather than shape. And we have squares and triangles again. And then here we have a client. And again, it's a factory, but this time we're dealing with shapes, iShapes, and we're calling a shape type.square. We know that because we know about the enumeration. We know about the different kinds that are there. If there's something in here that we try to call something that's a string, previously I could have said, in my previous example, I could be calling circle here, for example. And there would just be error. They would just get an error at runtime. Okay, whereas here I can just go. If I try to say circle, I say circle here. I'm trying to get this enumeration. I've got this issue and at compile time. So it won't compile because I'm looking for a shape that doesn't exist. So it's much better to use enumerations than be passing strings around. Okay, so I can run this one. And again, it's pretty much the exact same as last time. But again, it uses an interface in order to be able to affect the inheritance. And then I'm using this enumeration for selecting the kinds of shapes that I'm interested in. But I'm still using the shape factory. So, and this is the basis. So if you understand how this works, you should have no problem working with factory method and later with abstract factory. Okay. Let's go back to the notes. Okay. Okay, so factory method then, and I'm using the Dive into Design Patterns book here, and I'm also using a link on the website, on the refactoring.guru website, factory method. You can click through here, and you can see the page that's relevant, okay, for factory method. Okay, so we can do this. So also there's a nice description of the class diagram, and you can see here we have a creator class this time, and the creator and this is basically our factory. Okay, and it creates some products. Okay, and it has concrete products A, concrete product B, and then we have creators, which are creator A and creator B, which, and it works through this. Okay, so the whole point is that factory method is another creational pattern. It provides an interface for creating objects in the superclass, allows the subclasses to alter the type of objects that can be created. So we use factory method when we don't know beforehand the exact types of the dependencies of the objects that your code should work with, and the method. The factory method design pattern separates the product construction code from the code that actually uses the product. So it's easier to extend the product construction code independently from the rest of the code. And we can look at this diagram here. And if you go to the, if we go here and we work through, you can see the descriptions. So the product declares an interface that's common to all objects, okay, and this essentially is our shape. You'll notice the notation that's used here, whereas the interface and products, whereas, okay. And then concrete products, they're different implementations of the product interface, so we know about those. So we could have, the do stuff here could be our show and that we had with the shape, and these could be, square and triangles, okay, they implement those. Then the creator class that declares the factory method, returns a new Product objects, that's really important here. You can declare the factory method as abstract to force all the subclasses to implement their own versions of the method. And that's useful, and that's why this is an abstract class here. You can see this with the italicized, and then these are concrete instantiations, okay, of this, and that's it really, okay. And we can work through and see the pseudocode. This is an example that in the book to do with UI classes. I've written one for you that deals with shapes. So I should be able to go here, and I could go to my factory method. And again, what's important, please, that this core program is from the refactoring.guru website. I didn't write this main code. I used the code to make sure it works. And then what I did is I adapted it to use the same shape example that I used earlier for my simple one. So here we have a factory method. And what's nice here is that this is a very detailed and annotated example of code. Sorry, it's a very detailed example of how to implement this based on the actual UML diagram we saw earlier. So we've and loads of lovely comments here. So we've a creator class. It creates we have a factory method in here that creates a product, and then we have some operation, and then we have a product that's generated by the factory, and we have some information that lets us know what happens here. So what I've done, of course, is I've actually taken this, made some modifications, and created a shape generator. So instead of the creational method, I have a shape generator, and I again have a shape factory method that generates eye shapes. And again, I slightly changed the operation a little bit here. So I want to be able to get some shapes. And then Threats gives us this concrete creator 1, which is an instantiation of the creator class. Again, concrete creator 2, which is an instantiation of the creator class as well. And it uses the factory method, returns actual concrete products. Again, I produced a square factory. So if you're not sure what concrete creators are, it's a square factory, and then it just generates shapes and returns new square shapes. And then I have a triangle factory that generates new triangle factories. And instead of iProduct here, I'm using iShapes, and we have the operation that Shvet's included as well. And I have my draw and show that I would have had from previously. And again, so this then is my square shape, okay? And that just writes out how these work, okay? So this is the actual concrete class, okay? It inherits from my shape, using interfaces again. And here's my triangle shape. I'm using this one. It's no surprise there again. Now I have a client, and the client code here creates a concrete creator 1, concrete creator 2. So it's using this factory method to create these, and then one which is essentially for concrete products 1, concrete products 2. Remember, they're related. They all inherit from a product superclass, or in this case, an interface. For mine, I have a shape client where I have a square factory. So I generate a new square factory. I generate a triangle factory, and then I'm able to work with those factories. Okay, so it's no problem. I can actually do something with those very easily. Then my program, we have a new client, and we call the main, and then what that does is it kicks off this piece of code here, generates the factories, and does something with what's created from those factories. And in my case here, I wrote my shape client, and I was able to adapt the code to be able to do this. Let's run it. So I launched with a square shape, so that tells me that I was creating this shape factory, a square shape factory. And again, as the client says, I'm not aware of the creator's class, still works, and the same creator code just works. So I pulled out squares and triangles. And again, I'm following the example that was used in here. But I could adapt and change this so that it works and behaves in the same way as my earlier program. Please work through the code here. It's useful. Once you understand this code, you should be fine with look at the UML here. Once you're fine with the UML, you should be good with the code, and we'll just move back to the slides. So essentially what I've done is I've produced a shape factory here, and which was generalized, and I used this to generate square factories and triangle factories, which then used concrete classes to implement squares and triangles. and they were related. The point is that they're related to each other, products in some way. So the factory method, inheritance, is the easiest way to extend the default behavior of the library or framework. If you think in terms of, our solid, how does this design work or relate to solid? Well, if we look at the single responsibility principle, you can move the product creation code into one place in the program, and that makes the code easier to support. So it's great in terms of addressing the SRP. And if you want to look at OCP, the open close principle, you can introduce new types of products into the program without breaking the existing code. So I can introduce a circle class here, or octagon class or rectangle class. And it's here at this level. I don't have to worry, I can have a factory and I don't have to change any of these at all, okay? Okay, the code can become complicated, however, since you need to introduce a lot of new subclasses to implement the pattern. So you might have to move to or evolve into an abstract factory or to prototype or builder, depending on your actual requirements, okay? But from here up, it's fine, no changes, okay? And from here, it's fine. So you need to introduce this little layer here, okay? Still, it works well. Let's move on then to abstract factory. Okay, so again, even looking at the UML, you can see on the right, you can see it's a little bit more complicated here. Okay, so here we have a client again, that has an abstract factory, and you can see it's an interface, and we use this interface then to have a concrete factory 1. That's an instantiation of this, the concrete factory 2, it's instantiation, and each of these can create two different kinds of products, product A and product B, product A, product B, and then they will produce concrete products, which are all inherited from product B here, which is an interface or an abstract class. I guess this is an abstract class. And if it was an interface, it would have interface written here. Okay, so concrete product B, B2 and B1 both inherit from this abstract class, and product B, concrete product A1 and A2 inherit from product A. Okay, so we could look at this. So we have these abstract products. They declare interfaces for a set of distinct but related products that make up a product family. Then we have concrete products, and they're implementations of abstract products, and they're grouped by variance. Okay, so we can look at that a little bit later. I was thinking in terms of, I mentioned earlier where we might have shapes which are regular shapes, and we'd have shapes that are rounded corner shapes. So they would still be shapes, but they're still squares. You might have a concrete factory which produces rounded shapes, and then concrete factory that produces regular shapes, but we might want to produce product A, which are squares, and product B, which are triangles, and then, but this would be rounded triangles, rounded squares, regular triangles, and then these inherit from squares and triangles. So it's not too bad, So, yeah, we can have a look at this again. I took this UML comes from this particular website in terms of the abstract factory. You can click through again here, and you can scroll down, and you can look at this, and you can work through. It's nicely highlighted, so you can see how these parts work and talk to each other. There's pseudocode again for another GUI, and then there's some example code as well. Okay. So the abstract family defines an interface for creating all distinct products, but leaves the actual product creation to the concrete factory classes. So each factory type corresponds to a certain product variety. So, the factory square factory, but rounded square factory, or regular square factory, or shape factories. The client calls the creation methods of a factory object instead of creating products directly with a constructor call. Again, we're hiding this new. As a factory corresponds to a single product variant, all its products will be compatible. Okay, so if this produces product A and product B, and the variants of product A and product B, then they will all be compatible. The client code works with factories and products only through their abstract interfaces. You can see that. Okay, abstract interfaces here. Okay. That lets the client code work with any product variants created by the factory object. You just create a new concrete factory class and then pass it to the client code. That's how it works. It's kind of nice. So for our example, we might have something that looks like this. It might just be easier to read a little bit. So we have the shape factory again, but here we have a regular shape factory and a rounded shape factory. And a regular shape factory produces regular squares and regular triangles. And a round shape factory produces round squares and round triangles. But these are still triangles, okay? And these are still squares, okay? Because product A and product B, essentially, as we saw in the earlier UML diagram, are both produced by the factory, just a variant. And so it's straightforward to manage, okay? With the abstract family, you can be certain that the products you're getting from a factory are compatible with each other, okay? So you avoid this tight coupling between the concrete products and the client code. So let's again look at solid. We have our single responsibility principle. Look, you can extract the product creation code into one place, makes the code easier to support, and that's beautiful. OCP, you can introduce new variants of products without breaking the existing code, you know? So we could have we could have one called bezeled or beveled shapes if we wanted as well, and that would be fine too. Okay. The code can become complicated, again, lots of new interfaces, lots of classes introduce the pattern, but there's this level. But a lot of that's hidden from people, but at least you are not touching the existing code, so you're working from there. You'll notice that I say there's a demo here as well. So if I click through to here, the demo is not an actual demo. So what I did really is I just copied the code to look and run and make sure it worked. It's working fine, so it's a good base program. And I would normally start thinking about making changes to this particular one to deal with the shape exercise that I did previously, but I decided I'd leave that for you, okay? Because we only have an hour, and we only have 50 minutes in this particular class anyway. I wouldn't have time to go through it as well, and you need to do some work yourself. So if you follow the work that I did in the simple factory and the factory method, then you should be able to build an abstract factory as well using this base code here and this particular example, and also using this particular UML diagram. Gives you a sense of what's happening here. Okay, so kind of summary of creational patterns then. They provide various object creation mechanisms. They increase the flexibility and reuse of existing code. We didn't examine the two gang of four patterns called prototype and builder. And I'd recommend that you spend some time studying these yourself. So key things for you, you really need to look at the factory, the abstract factory implementation of that shape diagram in the previous one here. And also, you need to do this to be sure you get it, okay? Maybe look at prototype and builder. I would recommend you look at this. Builder is a creational pattern that allows you to construct complex objects step by step. Hence builder, the pattern allows you to produce different types and representations of an object using the same construction code. So you could, for example, use builder to make a shape that has features like presentation styles, etc. And you often see examples online using builder to make pizza objects, for example, or build a product by adding the various components. And I've seen examples of this building pizzas, of course, using factories as well, and not just builder. As a really nice example of how to use the building here by clicking through to the textbook and to the examples. And there's the final creational type is prototype, and that lets you copy existing objects without making a code dependent on their classes. Again, it's about making clones, okay? And you can look at the description of that here as well. Okay, so we learned about factories, and we saw two of the gang of four creational software design patterns. And we saw examples of implementation using C#. We looked at factories, okay? And remember, simple factory is just a way to get us going and understanding about the basic blocks for building factories. Factory method is all about inheritance, and then abstract factory is about composition, rather than inheritance in some respects. You could use these in your assignments. I certainly recommend, and I've recommended that you refactor your code from assignment 2, 3, or 4, where you're looking at shape generations, and replace all of that shape generation that you have currently with some factory method, okay? Or in fact, any of the creational software patterns will be fine. But let's look at the factory ones to get some practice in. Okay, we'll move on to a different one later on. That's that's the end of this particular class. If you've got questions, you can just mail me. As I said, this one wasn't live, but thank you for watching.